Okay, good evening. Now, today we'll be looking at the assignments we are given on Physics 112, exercises on error analysis. So let's go to the next slide. So we have that number one, if t equals to 2 pi square root of L over G, if t equals to 2 pi square root of L over G, and L equals to 100 plus or minus 0.1, and t equals to 2.01 plus or minus 0.01 seconds. Question here say calculate the value of G and its standard error. Now this is the solution to the problem there. Now first thing first, we were given the value of T, which is known as period for a simple pendulum. T equals to 2 pi square root of L over G. And we've been given the values of L and we've been given the values of T. Now, the first thing there that you need to take note of, the values after plus or minus is known as the standard error for each of the variables there. For L, plus or minus 0.1 centimeter is the standard error for the L. And for the period, plus or minus 0.01 seconds is the standard error. Now, for me to calculate my value for G, I'm going to linearize equation 1. What does that mean? I will take the square of both sides of this equation. So if I square both sides, in order for me to make G subject of formula, we will have T squared equals to 4 pi squared L divided by G. Because we know that square root will cancel square, or square will cancel square root. So if we make G subject of formula, we're going to have G equals to 4 pi squared L divided by T squared. So this is what we are going to use. This value of G here, that's what we are going to use in calculating our value of G and the standard error. Now the next one, we are going to impute all the values we are given in the question. We have in the first slide here, we have just 4 pi squared L over T squared. 4 pi squared L over T squared. Now, the 4 pi squared here, we're having L over T squared. We'll be giving L as 100, and you'll be giving T as 2.01 seconds. Your pi is a constant. So on imputing it, we have 4 times 3.142 squared times 100 divided by 2.01 squared. Now, when you punch these values in your calculator, you're going to have that per second squared because your length is already in centimeter. Now, the next thing there is to calculate the standard error in G. And this is the value. This is what we have for standard error, how we calculate standard error. In standard error, your constants are not necessary when calculating the standard error. So if you observe this question here, this formula here, we have G equals to 4 pi squared L over T squared. So what we're after G, which is a variable, we're after L, and we're after T squared. So to calculate the standard error, we have standard error in G divided by G all squared equals to standard error in length divided by length all squared plus 2 standard error in T divided by T all squared. The reason why we're having 2 here is this. For the first part here, we see that T is already squared in this equation here. We have T already squared in this equation. That's why we're having 2 multiplied by the standard error in T divided by the value of T. Now, to make the standard error of G subject of formula, because that's what we're finding here, we will take the square root of both sides, then multiply your square root by the value of G there. So we have G square root of standard error in L over L all squared plus 2 standard error in T over T all squared. Now we're going to impute our standard error in L, which is 0.1. Our value of L is 100. Our value of standard error in T is 0.01 divided by the value of T. G we got here by the answer. So on doing that, our answer will be 9.77 centimeter per second squared. So our value for G 7.42 plus or minus 9.77 centimeter per second squared. Now for the next one, we have number 2, the moment of inertia I of a meter rule of a rectangular cross section is I equals to BD squared divided by square 12. Calculate I and its standard error. If B equals to 2.66 plus or minus 0.01 centimeter and D equals to 0.65 plus or minus 0.01 centimeter. Now we've been given our value for I as BD squared divided by 12. That is our equation 1. The value for B is given as 2.66 plus or minus 0.01 centimeter and D equals to 0.65 plus or minus 0.01 centimeter. Now our SB here means the standard error in B and it's given as 0.01 centimeter. Is 0.01 centimeter, which is the value we're having here too. Now we will now substitute our value for I in this equation. We'll substitute our value for I in this equation. So the value for I on substituting the value for B and D in the 1, we have that 2.66 times 0.65 squared divided by 12. When we do that, we'll have that squared. Now, the next thing is to calculate our standard error in I. Now, if you can recall, our D here is squared. So we should note that when multiplying our standard error, we are taking the sum of the square of the standard error divided by the actual value. So we have standard error in I divided by I all squared equals to standard error in B divided by B all squared plus 2 standard error in D divided by D all squared. Now the reason for this 2 there is because our D was what? Squared initially. So making standard error in I subject of formula, this is what we are going to have. Now substituting the values we are having, the value for B and the value for D, our answer for the standard error for I is given as this, which will make our I equals to 0.09 plus or minus 2.79 times 10 to the power minus 3 centimeter squared. Now the next question. The next question says if a coupled MGR is applied at the end of a wire, the angle of twist theta at a distance L from a fixed end is divided by 2I. We calculate N and the standard error, given that the following value star equals to this, our M equals to this value, our R equals to this, and our acceleration due to gravity is given as this value. Now, the first thing we are to calculating the value of N there. Now, making N, these are the values we were given. On making N subject of formula, we are having N equals to 2I MGR divided by A theta. That means we cross multiply and divide it by A theta. Now, we'll now substitute our value for I, our value for M, G, R, A, and theta into this equation here. So, on substituting our value and multiplying and dividing, we will have this value there. Now, the standard error in N. Now, if you take note now, for your M here, there is no standard error given for M here, so it's taken to be a constant. It's neglected. Our standard error for G here was not given, so we're going to neglect it. So the rest values are known as the variables used in calculating our value for here. Now, making Sn subject of formula, we have n times the square root of the sum of the squares of these variables we are having in this equation. Now, substituting this value for your standard error and then the values for I, R, A, and so that our n equals to 29596.702 kilogram meter squared per radian second squared. Now, the next question says, in a given experiment, the following reading were obtained as the relation between two quantity X and Y obtained. So this is the table we're given. Now, the first thing we are asked to do is plot Y against S. Use 1 centimeter to represent 1 unit on both axes. A, measure the gradient of the straight line. Gradient also means slope. Yeah, the next one says estimate the error in the gradient. The next one saying, yeah, measure the y-intercept. And D here say estimate the error in the y-intercept. Now, if we take notes, when we were in our last class yesterday, I told us for every graph you have to plot, you must write the title of the graph. So the title of this graph is a graph of y against x. The next thing comes with your scale and your axis definition. So this is our graph. Our graph here is a graph of y against x. And our scale is 1 centimeter to 1 unit on both axes. Now, the next thing is to define our axis. We have the y-axis and we have the x-axis. Now, we were told vividly that on both axes, we are going to represent 1 centimeter to 1 unit. Now, for this type of graph, 1 centimeter is simply 5 smaller boxes. So we have 1, 2, 3, 4, 5 represent 1 centimeter. But from here to here represent 2 centimeter. So according to the units we were given, to the scale we were given, we plotted our graph. And like I told us yesterday, your line of best fit is simply the points that did not enter on both sides. They must be on equal quantity. So if you observe this graph very well, the point that didn't enter the straight line plots, yeah, we're having 1 and 2 here, and here also we're having 1 and 2 here. So we're having our best line of fit, or line of best fit here. Now, the next thing is to plot our slope. Our slope here is y2 minus y1, x2 minus x1. Now going back here, our y2 here is traced to be about 6.2, and your y1 is traced here to be about 1.8. Now your x2 is taking vertically downward to be about 8, and your x1 here taking vertically downward to be about 4. So we are having 7.3 minus 1.8 to be our y2.38 to be the slope of that graph. Now the next thing is standard error in slope. Now we have our standard error in slope to be 4w divided by n_r, where we say our w is the vertical scatter, your n is the number of points plotted, and our r is the horizontal range. Now let's go back. Now if you look at this plot here, our horizontal range is 8 minus 4. Then the vertical scatter is simply the distance between those horizontal points that did not enter on the plot here. So if we take the distance between these points and these points here, we'll see that our vertical scatter will actually give us approximately 0.4, and the number of points plotted is 7. So I'm fixing these values in this equation. Now, if you observe the graph here, there is no y-intercept in this plot. So we cannot calculate or find our y-intercept nor calculate the error in the y-intercept. So the next question, number 5, says the following table were made by a student. Now this is the table here. Our R is 1, 2, 3, 4, 5, and our 1 over R is 0.1, 0.05, 0.033, 0.025, and 0.022. We are asked to calculate what is the major error in the above table. Is it random error, systematic error, erratic error? And see here, say, is there any other faults you can detect from the table? Now, the first error here is known as random error. Random error, because the decimal points, the decimal place for 1 over r are not equivalent. So it is known as a random error. So B and A here, the question has been answered. Number A here said the major error in the table above is random error, and the next one is a random error. Now, the other fault detected from this table here is this. When we find 1 over r for this table, 1 divided by 1 here is not 0.1. It is what? 1. 1 divided by 2 here is not 0.05. It is 0.5. So the calculation of the value of 1 over r, the calculation for the value of 1 over r shows that The the error detected here is a random error. So we'll stop here for today. For today. We'll call today a class, and let's do it to join tomorrow's class by 8 p.m. Thank you and God bless.